In this video, we're going to start out with an introduction to section 3.2, and in this, what we're looking at are polynomial functions. We have been looking at special types of polynomial functions up to this point, and note that I am saying functions. With polynomial functions, that's just looking at something that has f of x is equal to, we'll say, a 3x squared plus 4x minus 5. That's a polynomial function. It's also something that looks like maybe g of x is equal to a 7x to the 6th minus 3x to the 5th plus a 4x minus 1. Both of these are polynomial functions. I have an x value, and that x value has a positive exponent. So it can't be negative, anything like that. We're looking at those with a positive exponent. So with both of these, I also want to look at something with what we've been identifying before, and that is the degree of a polynomial. With the degree of the polynomial, and if I could spell correctly, sorry guys. And so when we're looking at the degree of a polynomial, remember what we're looking at is that largest exponent when it is written in standard form. And remember, standard form is everything multiplied out, and we are looking at, not form. We are looking at that largest exponent. The other way to look at the degree of a polynomial is we are going to add the exponents for all factors with a variable. So I'm going to look at a couple of different ones here so that we can identify what exactly I'm talking about. So let's say that I have f of x is equal to a 7 x to the 5th plus 3x minus an 8x to the 6th plus 2. And then I also want to look at one that has g of x is equal to a negative 2x times an x plus 1 squared times an x minus 3 to the 3rd. So whenever I look at the first one with the f of x, one of the things to note is this is not written in standard form. Make sure that you rewrite it where the largest exponent is written first. And so if I rewrite this, it's going to be a negative 8x squared, negative 8x to the 6th plus a 7x to the 5th plus a 3x plus a 2. Now it is written in that standard format. And so with it being written in this standard format, the degree of my polynomial will be 6. It's my largest exponent. It has nothing to do with the coefficients, the numbers out front. It has to do with the exponents. Now, the second one for g of x, it's actually different. I said we add up the exponents for all the factors with a variable. So one of the things to note is this has 3 different factors. And each of those factors, because those are the things that are multiplied together, each of those factors actually has an x in it, a variable in it. So I have to look at this first one, and when I look at this first one, remember that this x has an exponent of a 1. And then this factor has an exponent of 2, and this one has an exponent of 3. So to get my degree, what I'm doing is I'm adding up each of these exponents together. So I'd take 1 plus 2 plus 3, which would again give me a degree of 6. So whenever it is in factored format, you have to go back and think about what it would look like if it was completely multiplied out. Part of the reason why we go over the degree, and we will continue going over different degrees and everything else as we go forward, we want to look at the end behavior of these polynomial functions. And what I mean by the end behavior is what it looks like on the graph. So think about those where we had maybe an f of x is equal to a negative 3x squared plus 2x minus 1. We looked at these back in chapter 2 as well as in chapter 3 in section 3.1. And whenever I look at this, a couple of things about the end behavior. I have to look at the sign of the leading coefficient. And so that's the number in front of the largest exponent. And then I also have to look at the degree of the polynomial. So in this case, I'm looking at this term right here. So my sign is going to be negative, and my degree is going to be a 2. So it's an even degree. With that being said, if you recall, when we were looking at these four parabolas, if it was negative, it meant that it went down. Okay? If my sign was positive, then it was going up. And if we think about a parabola, they both have degrees of 2, so they have even degrees. So if we're talking about the end behavior for any polynomial, the rule becomes for even degrees, if the leading coefficient is positive, we're going to have end behaviors where they both go up. Think about a parabola. They're both going up. Okay? If our leading coefficient is negative, our end behaviors, meaning where the arrows go, is what I'm talking about, what the arrows look like, they're both going to be going down. Now you'll notice that I kind of left a space here in the middle, and the reason why I did that was because if I have a larger degree than 2, I may have something that does some funky looking things in the middle, which we'll get to. But for now, I just want to look at the end behaviors. The other one is if our degree is odd. This is like our x to the third, or an x to the fifth, or anything like that. If our leading coefficient is positive, remember if it was positive for an x to the third, what happened was it had what we called a positive slope. So it was increasing, going from left to right. And then if it was the leading coefficient was negative, it was decreasing, going from left to right. A couple of things to note with this. You'll notice that with a positive leading coefficient, the right-hand side is going up. With a negative leading coefficient, the right-hand side is going down. Think about on your graph as you're going from left to right. Positive, we're going up. Negative, we're going down. And then if the degree is even, we are going the same direction. And if the degree is odd, we're going the opposite directions. So think about odd being in those opposite directions. So I want to look at a couple of examples before I leave with this video. So let's look at if I have f of x is equal to an x to the fifth minus a 5x to the third plus a 4x. And then I also want to look at g of x is equal to a negative 2 times an x minus 5 times an x plus 1 to the third. So let's first look at this f of x. If I look at my degree, this is all multiplied out. So I'm strictly looking at my largest exponent. So my degree is 5, which means that it is odd. So that's going to tell me that my end behaviors, since this is odd, is going to go in opposite directions. Now my leading coefficient in this case, remember we're looking at that leading term, it is going to be positive. So with it being positive, that means I'm going to be going up on the right-hand side. And since it was odd, remember, I was going the opposite direction. So one side is going down on the left and going up on the right. And if you want to, you can kind of draw them either way. A lot of times what we do is just look at their opposite up on the right, that type of thing. Either way of drawing those is fine. Now, on g of x, I'm going to look at my degree. You'll notice that I have 3 terms again, but that first term does not have an x value with it. So I don't have any x's, I don't have any variables here. The second term has an understood 1, and the third term has an exponent of a 3. So I'm going to take that 1 plus 3, so my degree is going to be 4, which is even. So even means they're going the same direction. My leading coefficient, if you look at this first term here, my leading coefficient is going to be negative. So if they're even and they're negative, that means I'm going down on the right-hand side. Even means they're going the same direction, so it's down and down. So I want you to practice some of just finding what the leading coefficient is and the end behaviors. And in the next video, we'll talk about how to use them to actually graph items.